morning. We are here to make you an interview about computer vision.
Computer vision can be defined very easily it's a very easy idea at the end. Is you take some images, maybe one image or maybe a sequence of images, a video, and then you extract information useful for one application. So this is different, for example, from what you do with Photoshop, in which you take images, then you do something with the image, and then you get another image. And so computer vision is more about to extract useful information. For example, when you are dealing with cars, then maybe you are interested in the number plates, and then you have to extract this information from the image. So you get a text that is just the digits and the numbers, the digits and the letters that you have in the plate. And so this is a computer vision definition to make it really short. So I'm in this business from 1999, and so I did my final work for computer science, and then I was attracted about computer vision because it's something that you do with a camera attached to a computer, and then you can do something with the environment. You can do something that is not programming and just seeing something in the screens, but to get something from the environment and to do something with the environment. And because in the beginning I was very attracted about robotics, and so computer vision is the perceptual part of robotics. The first thing we were doing was something about faces, tracking faces and dealing with fast motions and these kind of things. And after that, I have continued working on faces, just facial expression recognition, demographic analysis, for example, seeing the face and being able to say, this is a man, this is a woman, extracted the age, for example, of the person, identify faces, tracking faces, for example, to see if somebody is looking to a concrete place or whatever. And so faces is the main thing I'm doing, and so I'm very interested in this kind of in this kind of object, the face, because the applications you can do with the faces are a lot. Nowadays it's used in a lot of fields. For example, you can see every day when you go to Google Street View, then you can see that any face is blurred, and any car plate is blurred too, so you can see that every day if you go to the internet. There is a lot of computer vision in your business, in post-production of video, for example. Now these tools you can use, in which you can put a virtual object into the real sequence, are done with computer vision. So you have to auto-calibrate the camera and see and extract where the camera is with respect to any object in the scene, and then you can put a real object there, a virtual object there. It's done with computer vision. It is maybe the computer vision of the 90s. In the 90s, during 10-15 years, a theory about how to do that were developed, and now we have a lot of tools that can be used in post-production. Also, computer vision is used in movies, for example. The Avatar thing was done with motion capture, and at the end is looking at the face with the camera attached to the helmet, and then you can do this kind of things. Computer vision is also used in medicine, in medical images, because you have to extract or to see, for example, tomography images and see if there is something wrong there in the body. And so if it is done automatically, then it is easier for the radiologist. And so this kind of applications are very nice. Now we know that we can do something in some applications, and so we say we call this field computer vision. What we can do with a computer and a camera, and then we don't like to do exactly the same thing that the brain is doing, because it's very difficult. And so we do something with some applications. And for example, now the most exciting thing about computer vision is the categorization thing. It's trying to do what the brain is doing. For example, in this room, saying, okay, here there is a table, there is a chair, there we have lights, there we have a backpack, or whatever. And so people is doing, is improving the capabilities of localize some objects in the scene and then categorize them. And so this is the things that people are doing with computer vision. And this was very difficult maybe 5 years ago or 7 years ago. We were not able to do that. Usually in computer vision, the problems we have is mathematical ones. At the end, if you do computer vision, you are dealing with mathematics, and so you are dealing with a theory. At the end, the field is a scientific area. At the end, so you have a problem. For example, we are going to track a face, and then you have to propose a model of the face of the object, and how is it moving, how is the light affecting this object, and then this model is an equation or two equations or something that is related with mathematics, and so you have to test the validity of this model in some experiments, and then see if your hypotheses are right, then you get nice results. The biggest problem always is that you have to learn a lot, and you have to deal with a lot of things. Always when you are doing computer vision, there are works that are really nice. We call in the field, we call them seminal works. So maybe once in every 3 years or something like that, you get, or somebody come to the field from another engineering part or another mathematical part or physical part, and get something or bring something from these fields that they already knew, and then they solve with this technique. They solve an open problem in computer vision. For example, GraphCADS is a technique that in 2001 was coming from mathematics, from optimization, and then a lot of people is using that for segmenting images. That is to locate parts of the image that belong to an object, for example, a person, or in medical imaging, to separate I don't know, the liver from other parts of the image. And these techniques are very important. And then you see these papers or these works and say, wow. Or in tracking, for example, Lucas and Kanade. Kanade is a Japanese guy that is working in Carnegie Mellon University. And so this seminal paper from the beginning of the 90s is really interesting. And then you see this work every now and then. And so usually every some years you get something that is, wow, this is a breakthrough. They have solved a problem that was not solved. For sure, is science. In the beginning of computer vision or image processing, we had more people in trying to do things not with mathematics. And at the end, when mathematics is in computer vision, and people from physics, and people from statistics, and people from optimization came to the field, then a lot of things were solved, because it's really scientific field.
I think that's all, and well, it has been a pleasure for us to make this interview. We hope you have enjoyed it, and we think we have enjoyed it as well. So it has been a pleasure, and thank you so much.